Example 16.13 gives us another look at sketching the graph of a rational function. Here we have g of x equals x minus 4 divided by x squared minus x minus 6. So in order to be able to start my process, I need to know what the domain is going to be, and I really need to get the denominator factored on this in order to be able to do that. So the denominator is going to factor nicely as x minus 3 times x plus 2, and my numerator doesn't need to be factored. I'll just leave it as x minus 4. So the domain for g is going to be negative infinity to negative 2, union negative 2 to 3, union 3 to infinity. And with that, we see that there are going to be two discontinuities here. So you're going to need to test those out. You're going to need to test out g of negative 2 as well as g of positive 3. So when you plug those in, you are going to end up with g of negative 2 being negative 6 over 0, and g of 3 is going to end up being negative 1 over 0, which are both undefined. So that means that these two things together are going to give us our discontinuities. Vertical asymptote located at x equals negative 2, and vertical asymptote also located at x equals 3. Since those are the only two discontinuities, I know that there are not going to be any holes in this graph. Let's move on to the horizontal asymptote. For the horizontal asymptote, I will recognize that this is a bottom-heavy rational function. Degree of the denominator is larger than the degree of the numerator. So the horizontal asymptote has to be y equals 0. Going on to the intercepts calculation. For the x-intercept, I will let g of x be equal to 0, which is then going to give me 0 is equal to x minus 4 over x squared minus x minus 6. Now we saw on example 16.12 that we can multiply both sides by the denominator, because that will allow the denominator to be canceled on the right-hand side. But on the left-hand side, since we're multiplying by 0, we're just going to end up with 0 equals x minus 4. And that would imply that x equals 4 is the 0 for this function, and that is to be interpreted as the x-intercept located at 4, 0. Your y-intercept calculation can be done similarly. For your y-intercept, we're going to be looking for g of 0. Well, what's going to happen if we actually plug in 0 for the x's? So that's going to be 0 minus 4 over 0 squared minus 0 minus 6, which is going to be negative 4 over negative 6, and that will reduce to be 2/3. So the y-intercept is located at 0, 2/3. Let's go ahead and plot what we have before moving on to the t-chart step. Most recently, y-intercept, that's at 0, 2/3. X-intercept is going to be at 4. And vertical asymptotes, we have 2. We have one at negative 2. And we have one at positive 3. And then the horizontal asymptote is going to be y equals 0. So with that said, we are going to create 3 t-charts because our domain is written in 3 intervals. We'll have one t-chart here for the left piece. We'll have a t-chart here for the middle. And then we'll also make a t-chart here for the right hand side. Let's just start with the left and work our way to the right. Over here on the left, we don't really have anything except for the vertical asymptote and the horizontal asymptote. So we're definitely going to need some points. I'm going to pick -6, and I'll also pick -3, just to try to get them spread out a little bit so that way I don't have them too condensed together. It'll help me to see the curvature if there is one. -6 is going to map to -5/18. -3 is going to map to -7/6, which is -1 1/6. So both of these points are going to end up being below the horizontal asymptote. -6 is a little bit below. Over here at -3, we're going to be at -1 1/6. So here's a really good example of where I don't think we need a third point, because these 2 points are already so close to the asymptotes that it's very natural for us to connect them and then just make this curve to fit within the boundaries. Now, if you don't feel comfortable with that, then you would probably want to add a third point. You might come in here and look at maybe -2.5, see what's going to be happening there. So you don't just have to plug in integers. You can plug in any real number that's from the domain. So that leaves you a lot of options, whatever you feel comfortable with. Let's go to that middle interval from -2 to 3. Now with this one, we already have the y-intercept. So I'd like to know what's happening to the left of the y-intercept. So I'm going to pick an x value of -1, and then I'm also going to pick an x value of 2 to see what's happening to the right of the x-intercept. -1 is going to map to 5/4, which would be 1 1/4, and 2 is going to map to 1/2. So let's mark those 2 points. And I can see that there is a decreasing trend here to connect these 3 points. Now that certainly plays a significant factor in how do I come over here to the left as I approach the vertical asymptote at -2 from the right. So I can continue with that decreasing trend, but I really shouldn't continue the decreasing trend into the next vertical asymptote. So at this vertical asymptote, we are going to do one of 2 things. We are either going to go like this, or we are going to end up going like this. I can't cross the vertical asymptote. I either have to approach infinity or I have to approach -infinity. Now we can plot another point. We could go to, say, 2.5, and we could figure out which way it's going to go. Or we can think about the x-intercepts. If the graph goes down, then that means I'm going to have to cross the x-axis, which means I'm going to have another x-intercept. But I don't have an x-intercept there. So that would automatically eliminate this as being an option. So therefore, the graph has to go toward positive infinity as we approach the vertical asymptote. So there's a way for us to logically justify that without having to make another point. But certainly, make yourself another point if that makes you feel better. For the last part here, the last interval, I am going to need to start with probably 3.5, since I have an x-intercept at 4, but I don't really know what's going on in between the x-intercept and the vertical asymptote. So 3.5 will help with that. And then I'm going to also pick 6, so that way I can just be a little bit further away from the x-intercept on the right. 3.5 is going to get you approximately -0.18, and 6 is going to get you exactly 1/12. So let me mark 3.5 just a little bit below the x-axis, and then 6 is going to be just a little bit above the x-axis there. I can get that marked. There we go. So I can connect these, but I have to do so very carefully. make sure that I'm heading toward the end behavior, trying to flatten out there toward the horizontal asymptote, and then on the left I'm just going to approach negative infinity, and that's how I will get the third interval, giving us the complete graph of G.